All right, guys, the bread's in the oven. Let's get to work. Okay, so here's what we're doing now. We're going to talk about a series. And basically what a series is it is the sum of the elements in a sequence. So a sequence was just looking at a list of terms. And now we're saying, hey, we're in calculus. What happens if we add them together? So first off, let's talk about just the notation. So the notation we use looks like this. So it's called a sigma notation because it uses the Greek letter sigma. But you take the sigma, say n equals 1 to 5 of a sub n. So when you see this, what this means is this is like a sum of the terms of a sub n from n equals 1 to n equals 5. So it's kind of like an integral in the sense that we have a starting bound at the bottom and we have an ending bound at top. So this is just saying take a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. So if I ask you, for example, what is like the sum from, say, 1 to 4 of 1 over n? So what this is saying is this is just saying like basically plug in all numbers from 1 to 4 and then add them up. So it would be 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And that's just like some random decimal, obviously. Okay, so if I ask, for example, like what is, the sum from n equals 0, let's say, to n equals 5 of n squared. Well, then that's saying let's do 0 squared plus 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So that's 525, I don't know, it's a big number. It's like 5 plus 9 plus 16 plus 25. So that's 25, it's 55. Okay, cool, interesting. All right, so that's what's going on there. And that's the notation that we're using for just adding together a couple of these. Now, of course, we're in calculus, guys, so we're not just trying to add 5 numbers together. Our goal, because this is calculus, is to add an infinite number of numbers together. Now, I know that seems weird, that we might be able to add an infinite number of numbers and just not always get infinity. But what happens in some of these cases that we'll see in just a moment is that some of these numbers just get so small that as n gets bigger and bigger, those numbers just get infinitesimally small, that no matter how many you add, because they just keep getting smaller and smaller, they never actually add up to anything. And we'll go over some examples in class. But the general idea here is to take the sum from 1 to infinity of a sub n. So again, this is summing of all terms that are greater than or equal to 1. So this is just saying a sub 1 plus a sub 2 plus a sub 3 and so on forever. Like there's no endpoint, you just keep adding. And the vocab we're going to use, of course, should look very familiar, is if this sum is a number, we say that this series, and the series is just the name for the sum, this series converges. Okay, and if the sum is infinite, we will say this series diverges, or this sum diverges. And of course, when we're talking about this, really, of course, this is actually a limit. This is just saying what is the limit as n goes to infinity, k goes to infinity, let's say, of the sum from 1 to k of a sub n. So, you sum from 1 to 100, 1 to a million, 1 to a billion. What happens to that upper bound goes to infinity? That's what's going on there. That's not super important, but it is what it is. Okay, so let's take a look just at some simple examples, right? If we say, for example, the sum from 1 to infinity of n squared. Well, this sum is like 1 squared plus 2 squared plus 3 squared plus 4 squared. I think we can all agree, just by looking at this and thinking, this sum is going to be infinity. This series diverges. Okay. But what about the case where, for example, let's say we take the sum from 1 to infinity of 1 divided by n squared. Well, if you take a look at this, this is like, 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16. Well, I don't know about that, right? Because what we see is that the terms are getting really small. So hopefully that offers like a glimmer of hope in your mind that maybe, just maybe, this might add to a number. And in fact, it actually does. I'll tell you what that is later. But that's the idea, is that these numbers are getting really, really, really small. So when you add an infinite number, it might actually approach some number as you keep adding them. So we're going to talk about something called the limit divergence test, also known as the nth term test. And we're going to be learning probably close to a dozen tests over the next week, or next couple weeks. But all it does is it tests to see if an infinite series is convergent or divergent. And that's our big question in this chapter. If I give you a series, does that series converge, meaning it adds up to some number? Or does it diverge, meaning that it adds up to infinity? We're not even necessarily going to find out what it adds up to, but just whether it does or not. Okay, so anyway, that's the idea of what a test is. So here's what the limit divergence test, or the nth term test, says, is take the limit as n goes to infinity of each individual term. And if that limit is 0, all that tells you is the series might converge. It might converge, it might not. We're actually going to get more into that in the next lesson. But if the limit is not 0, that means that the series diverges, for sure. And let's talk about why. And this is kind of the more important part. If you take that limit of the terms, if those terms individually are going to say 4, well, when you take the sum of those terms, that's 4 plus 4 plus 4 plus 4, and so on, that's obviously going to be infinity. But if those terms are going to 0, then you're doing 0 plus 0 plus 0 and on and infinitely. Yeah, maybe that actually does just add up to a number. So that's kind of what we're trying to do. Just take that limit of each individual term, just like we did with a sequence. And if that limit is 0, the series, which remember the series is just the sum of the terms, that series might converge. If that limit is not 0, that series diverges. Okay, so let's look at some examples. And we're not going to be able to get better than diverges or might converge until the next lesson, but that's going to be what we're going to try and do today. So I'm going to give some examples and say, does this series diverge for sure, meaning that the limit is not equal to 0, or is it possible that the series might converge? Okay. And again, this is truly a might converge, and that's going to happen when the terms do go to 0. So let's look at some examples here. So let's suppose we have, the sum from 1 to infinity of 1 divided by 3 to the n. So what we're going to do, again, the first thing we're going to do, and all we really can do today, is take the limit of the terms. Basically saying, what does the sequence go to? Not the sum, but what is the sequence? So we take a look at this limit. So we look at the limit n goes to infinity of 1 over 3 to the n. So of course that's 1 over infinity, which is 0. So we go back to here. The nth term says, all it says is if the limit is 0, the series might converge. So what that means is that the terms are approaching 0. So that actually means that the sum might converge. And that's all we can do today. Later on, we'll be able to tell that this series definitely does converge. Today, it's just either might converge or diverge. Okay, let's look at a few more examples and see if we can explain it. Again, it's just saying that as we get bigger and bigger with these terms, with these n values, those terms go to 0. And the sum obviously is going to be bigger than 0. It's actually 3/2 if you're curious. But the idea is that if the terms get closer and closer to 0, the sum goes to something. Okay. Let's look at a couple more examples. So let's suppose we take n goes to infinity, n equals 1 to infinity of just 3 to the n, so no fraction. So again, let's take a limit of the terms. So limit n goes to infinity of 3 to the n is 3 to the infinity. Well, this is infinity, but the important part is that it's not 0. So because that limit is not equal to 0, that tells me that this series that I get, and series really just means the sum. When we talk about a series, we're talking about a sum. That series diverges, for sure. Okay, which makes sense, right? These numbers are just getting larger and larger, right? They're 27, 81, 243, 729, and so forth. Okay, now let's look at another couple of examples here. So let's say the sum from 2 to infinity of 5n plus 3 over 4 minus 9n. All right, so again, we're going to take a limit of the terms. So we're going to take a limit as n goes to infinity of the equation of the term. So 5n plus 3 over 4 minus 9n. Now, you can L'Hopital this if you want, or you can look at the leading terms. It doesn't really matter, right? It's an n over an n. So you can see we have a 5n and negative 9n. So that means that this limit is equal to negative 5/9. Okay, so let's not get confused. What that means here is we just looked at the terms. That means that the terms approach negative 5/9. But negative 5/9 is not 0. So because that's not 0, that tells me that the series that we get from adding the terms together diverges. Which makes sense, because if the terms approach negative 5/9, and this is like our answer, you're done. Because if you take the sum, if you add these together, you do negative 5/9 plus negative 5/9 plus negative 5/9. I think we can see that adding a bunch of those together is just going to go to negative infinity. Right? You keep adding terms like negative 5/9, and you add those infinitely, and that's what happens. Okay. And then finally, let's just look at one more example. Let's suppose, for example, I don't know, we have the sum from, say, 1 to infinity of e to the n divided by 10n squared. So you want to take the limit here as n goes to infinity of e to the n over 10n squared. Now, this looks like a case for L'Hopital's rule. So we do the top and the bottom separately. So we take a limit n goes to infinity e to the n, which is, of course, infinity. So you do the same on the bottom, 10n squared. That's also infinity, so we L'Hopital it. So this becomes the limit n goes to infinity of e to the n over 20n. Anyway, you end up L'Hopitaling again. So it's the limit n goes to infinity of e to the n over 20, which goes to infinity over 20, which is infinity. This is just L'Hopital. I just went quickly through it. Anyway, so again, infinity is not 0, so that means that this series diverges. Okay. So that's the idea today. If that limit is 0, it might converge. So if I had flipped this fraction, we would have got a limit of 0. So we'd say it might converges. But because we got a number that's not 0, it diverged. So that's the idea here. The only time we have a series that might converge is this case, where we had the terms that were approaching 0, and that's what we can say. So just a couple notes. If the terms go to 0, summing infinite numbers of a sequence can give you a number. And I know this is really odd that we could add an infinite number of numbers together and just get 3 or 10 or 4.5, but it is possible. And the other thing is if the terms go to 0, this truly is just a might. If terms go to 0, this is a might. And this is just going to be a little preview to our next lesson. But for example, the series of 1 over n, the famous harmonic series, actually does diverge. But the series of 1 over n squared actually is a convergent series. And again, that's something we're going to go over tomorrow. But in both of these cases, right, if you take the limit n goes to infinity of 1 over n, you get 0. If you take the limit n goes to infinity of 1 over n squared, you also get 0. But you get different outcomes. And that's why it's so important that today all we can say is that if the terms go to 0, that is the only possible way that that sum might converge. And if the terms do not go to 0, of course, it definitely diverges, right? Because 5 plus 5 plus 5 plus 5 is obviously infinite. Okay, big conceptual ideas here. Thank you guys so much for watching. Please bring me some questions to class. I'm going to go get my bread out of the oven, and I'll see you guys soon.